Hello and welcome to this AWS webinar. My name's Ian Massingham. I'm a technical evangelist with Amazon Web Services located in Europe, and I'm going to be your host for this session today, the first in our series of masterclass webinars for 2015, and today we're focusing on AWS CloudFormation. The masterclass series are a series of webinars where we deep dive into specific AWS services, so that's going to be the focus for this session today. We do have another webinar series called the Journey Through the Cloud series of webinar, which is more focused on a solution-orientated look at a variety of different AWS services and how you might apply those into one particular area of use cases within your organization. So that might be, for example, running development and test workloads or disaster recovery on AWS. And you can find the details of the webinars in that Journey Through the Cloud series. If you take a look at the links panel in the webinar interface, you'll be able to see a campaign page for those other webinars there, as well as one which will show you what else we have coming up this year in the Masterclass webinar series. If you're watching on demand, you'll also find those two links in the video description for the video that you're watching here. Elsewhere in the live interface for this webinar, you can see a materials download panel called the Files panel, and you can grab a PDF of the slides that we're using in the session today if you click on the link that you can see there. And that's useful to get, mostly because there are several, actually quite a few references and URLs in the slides that we're going to be using for today's masterclass session. And if you grab the PDF, you can simply click on those URLs in order to access additional resources and additional material that will help you learn more about today's topic, AWS CloudFormation. If there's anything that we don't cover during the session today that you would like to know more about that, CloudFormation related or otherwise for that matter, anything to do with AWS at all really, please ask us questions using the Q&A panel, which you can also see in the live webinar interface. I will try to answer as many of those as possible at the end of the session today, and if we can't cover them, a member of our solutions architecture team here at Amazon Web Services will get back in contact with you with an answer, and with some further reading in many cases for resources that you can check out to learn more about the question that you might have asked. Also, at the end of the session today, a couple of other things. You'll be shown some social media links in addition to the Twitter details that you can see from me on the screen right now, some other social media links. So get ready to either make a note of those or follow us on Twitter at the end of the session. You can stay up to date with future AWS educational events here in the English language in the European time zone, and also live events that AWS are running here in the UK and Ireland and elsewhere across Europe. And lastly, at the very end of the session, we will switch the webinar today into a different mode, into Q&A mode. And when we do that, you'll be given an opportunity to rate today's session. We'd really love to get some feedback from you on how we've done with this webinar today, things that we could improve upon, most importantly, maybe some things we've done well. And we'll ask you to give us a score from 1 to 5, with 5 being the highest. So please do give us your feedback at the end of the session. It's really helpful for us in making sure that we optimize the webinar experience for future customers that might be visiting this series in future years. Okay, so that's enough housekeeping. Let's get started on the content for today's session, which is of course a masterclass focusing on AWS CloudFormation. Just to recap what we're going to cover in the masterclass series more generally. So we're looking at a technical deep dive here that will go beyond the basics of a specific AWS service. We want to educate you on how you can get the best out of, in this case, AWS CloudFormation, show you how things work and how you can get things done with the specific service that we're going to focus on in today's session. And we're focusing on AWS CloudFormation here. So that is an easy way that enables you to create and manage a collection of AWS resources using a templating language called CloudFormation Templating Language. That template will allow you to provision and update AWS resources in an orderly, predictable and repeatable fashion. And that enables you to version control your AWS infrastructure, following a trend which is becoming more widespread now actually than it was when CloudFormation was first created, which is to define the infrastructure that supports your application as code, at version controlling your infrastructure in the same way that you might version control releases of your code base or releases of static data that might be incorporated into your application. It enables you to deploy and update stacks using either the Amazon Web Services console, the command line, or the API. And of course the API is wrapped by a variety of different SDKs, Python.NET, Go is recently released or announced rather, and others, so you can control CloudFormation using those three different mechanisms. And in common with, I think, all AWS deployment and management tools, you only pay for the resources that you create with AWS CloudFormation. So CloudFormation itself is a service without charge, but as and when it creates resources within your account, you'll then be charged for the resources that this service creates. Okay, that's quite important to bear in mind. So the simple basic characteristics really of AWS CloudFormation. Firstly, you don't need to reinvent the wheel. So with AWS CloudFormation, the templates that you create, you can use them repeatedly to create identical copies of the same stack, or maybe as the foundation to start a new stack of resources that you want to create. And you can capture and control region-specific variations, such as EC2 AMI or Amazon Machine Image IDs, EBS or Elastic Block Store volumes, or RDS Relational Database Service snapshot names within your template. So it allows you to have this characteristic of reuse. The templates themselves are simple JSON formatted text files, and that obviously means, as we said earlier, that you can place these under normal source or version control mechanisms, and you can store those in public or private locations such as Amazon S3, exchange them via email, and you can take a look at these templates and see exactly which AWS resources make up the stack that you're going to create, and you have full control to modify any of the resources that are created as part of a stack, either by changing the template itself and doing an update, or by working directly with the AWS resources themselves if you wish to do that. The templating language is declarative and it's flexible, so you can create whatever infrastructure you want, essentially, enumerating AWS resources, configuration values, interconnections that you might need within your template, and then you can let AWS CloudFormation carry the heavy lifting of creating those resources just by executing that template via the management console, using the command line interface that we provide, or by a single request to the AWS API. And then you won't have to remember the details of the resources in that stack for future creation activities. Once you've written that template, you can use it as many times as you wish, of course. And in many cases, you won't need to write these templates from scratch. I'll talk to you later in the session today about sample templates, provide some really good resources of example templates that you can use either as a whole solution for certain stack creation activities, or as a baseline from which you might derive a modified stack that suits your purpose exactly. So definitely you can take a look at making use of those samples, and we'll cover that in much more detail later in this session today. You have the ability to customize stacks, so you've got execution time parameters that you can pass to your template at runtime, essentially. When that stack is built, those parameters will be used. So you could pass in things like RDS database size or instance types, database or web server port numbers, and this can enable you to use parameterized templates to create multiple stacks that differ in controlled ways. It's obviously very good if you are, for example, using one stack definition to create development and production environments. In that scenario, you may wish to create development with smaller EC2 instance types than your production environment in order to help you cost optimize as effectively as possible. You may want to do different things in different regions where you're creating stacks, and you can use these template parameters to tune settings and thresholds in each region independently of one another, while still maintaining consistent infrastructure deployment across different regions or different environments. That's a really helpful feature of this service. You've got integration ready capabilities, so you can integrate CloudFormation with development and management tools of your choice, whether that's a CI/CD deployment tool or other development and management tools that you may use. The programmatic access to CloudFormation via CLI, SDKs and APIs makes that very simple to do. And CloudFormation publishes progress events through another service called the Amazon Simple Notification Service, or SNS. So not only can you initiate stack creation actions or update or deletion actions using those programmatic interfaces, but you can also track stack creation and deletion progress via email, or integrate with those updates programmatically using other interface mechanisms that are available. So that's really helpful for integration. And then lastly, as we said slightly earlier in the session today, there's no charge for CloudFormation in its own right. You only pay for the resources that CloudFormation creates and your application uses to operate. So CloudFormation itself is available at no additional charge. How does the service work? Well, as we've already said, we have these JSON formatted CloudFormation templates that contain parameter definitions, the resources that you wish to be created, and configuration actions that you might wish to execute. Those templates are executed by the CloudFormation framework, which handles stack creation, stack updates, error detection, rollback, and of course stack deletion. So the engine operates on those templates, and by operating on the template, it will create this stack of configured AWS services for you. There's very broad support for different services. There's good awareness of events that might occur on services, and you can actually go further and customize the services that are available to extend beyond AWS provided services, and we'll talk about that later in the session today as well. So that's a quick intro. What are we going to cover in the rest of the session? Well, we're going to talk about creating templates. We're going to talk about how you would use a template to create and manage a stack of resources. We will cover working with AWS resources, and we'll also talk about bootstrapping applications and handling updates. So let's kick off with a quick discussion around how you create templates. And as we've said earlier, the templates themselves are JSON format, so they're essentially text files. They allow you to manage the relationships between different resources within your stack. They have these reusable characteristics using either parameters or another technique that we'll talk about later that helps you avoid namespace collisions. That's an important characteristic of CloudFormation, actually, the fact that it helps you avoid collisions in your namespace. The templates themselves provide feedback and provide some capability for debugging stack creation activities that might fail or not behave as expected, and we'll cover that in detail when we talk to you about how you use the console to initiate stack creation. There's no compilation step, obviously, because these are text files, so you've got this write and go characteristics. You can do lookups, and as we'll show you later in this first section, you can also automate the generation of these templates. It kind of loops back because they're JSON files. Any tool that can output JSON compliant text files can be used to create CloudFormation templates. We'll cover that in a few minutes. So the high level structure of a template comprises four main areas, really. A description, which is simply a text description of the template's usage, maybe what it creates. Parameters, which are the inputs used to customize the template per deployment. As we said earlier, you might use that for using the same template with different EC2 instance types, for example. Resources, the set of AWS resources that you're going to be creating and the relationships between them. And then outputs, which are the values that are to be made visible to the stack creator once stack creation has completed. And we'll break this down by taking a look at a sample template now, just to show you very simple definitions of these four different parts of your template. So you can see the description now at the top. This particular template creates an EC2 instance running the latest Amazon Linux AMI or Amazon Machine Image. At the parameters there, you can see we're going to ask at template runtime, for a key pair, which is the EC2 key pair to allow SSH access to the instance. We're going to expect a string in response to that. So you'll be asked to enter values for parameters when you create your stack, or pass them in on the command line if you're using the CLI. Resources, these are the resources that we're going to be creating. Statically defined properties such as image ID and instance type. We've got a reference here to that key pair parameter that we asked for at creation time. And the image ID in this case is the AMI specific to the region that you're going to launch this stack in. In this case, we're looking at the EU West 1 region. That is the image ID for the the latest Amazon Linux 64-bit HVM AMI or ARMI. So that's the resources that are going to be created by this specific template. And then outputs, I'm going to output in this particular instance the instance ID for the newly created EC2 instance, and that's it. It's that simple. So those are the outputs that will be returned once this template has completed execution. And it's quite normal for customers that are relatively advanced users of AWS CloudFormation to integrate template creation with CI/CD tools. So you can see here a typical support environment for a software development project, including a source code repository server, a CI server, project management tools, and then builds stored as artifacts in Amazon S3. And what we see with customers that are more advanced, more sophisticated users of CloudFormation is they will quite often create a CloudFormation template as part of their continuous integration, continuous deployment pipeline. And they'll create that CFN template that deploys the latest version of their application on top of a fresh stack of infrastructure. We'll come to later in the session how you can do application bootstrapping with AWS CloudFormation. But I just wanted to show you that this is a very common model for customers that are evolved users of AWS CloudFormation. The template generation process itself is something that can and is automated by these customers. One common tool which is used for this is a Python tool called Troposphere, which is a library enabling you to create CloudFormation descriptions using a Python-style syntax. So you're basically writing Python code that describes the resources, and then the Troposphere tool itself will output you a CloudFormation template based on the Python code that you've created containing your definitions. You can find some more detail about that and actually download it from the GitHub repo that you can see on the slide there, github.com/cloudtools/Troposphere. But remember that CloudFormation is just JSON, so any tool that can generate output in JSON can be used, either a third party or tool that you might create yourself. Of course, a variety of text editors. You can make use of JSON validation plugins with things like TextMate or Sublime Text to enable you to validate your JSON output visually before saving it and then using it to drive this next step, which is the creation and stack management process. So the first thing you're going to do here, as we've already said, is to create a template that you're going to use to manage your stack. Okay, and here we're using a simple text editor. I think in this case, this screenshot comes from TextMate on a Mac. So we've got our JSON file there that you can see contains the same sample template that we used a second ago to talk you through the structure of the templates. Then jump onto the AWS console, and you'll see that in the deployment and management tools section of the console, there is a CloudFormation section there. And if you click into that CloudFormation section, you'll be presented with this screen. And as we're going to be creating a new stack, we're going to select the Create New Stack option here. And that will then take us onto this wizard-driven section of the CloudFormation console. We're asked to enter a name for the new stack that we're going to be creating. In this case, we're going to be creating the EC2 instance demo stack. And we're then asked to identify where we're going to find the template, the JSON formatted file that describes our stack's resources and their properties. And in this particular case, we're going to upload a template to S3. So we're using the file system browse there to upload the template that we previously saved out of our text editor a couple of seconds ago. But we could, of course, use a sample template there, as you can see at the top, or specify a pre-existing Amazon S3 template URL. And of course, best practice here would be to use IAM to restrict access to the specific S3 buckets or prefixes where you are storing those templates. If you don't wish to make them public, you should always do that, of course. You then be asked to specify the runtime or execution time parameters for your template. And you'll recall from our example a second ago, we had a key pair that we would ask for here, which is an EC2 key pair to enable SSH access to our instance. And we're going to use a pre-created key pair in this particular instance, one that we've already got saved inside our AWS account in this specific region, which is called management key pair. Click next there, and then you'll be asked to name your stack. So this is a important component if you've got a significant number of resources within your account, because it will enable you to identify your stack later on if you wish to clean it up or modify it. So name your stack. We just called out a stack name in this particular case. And click next. And then in common with many AWS services, as I'm sure you know, you're then asked to review precisely what it is you're going to be creating, and it'll reflect back to you the details of what you've asked to be created, the template, the parameters, the options, and any of those advanced options that you may have selected. Then hit create, and you're on to the creation process. And what you'll see here is the events console, or events panel rather, in the bottom half of the console will be populated. It will notify you when there are more events available to display. And if you click on that button, as I've done here, you'll see that You're then provided with an event stream, essentially updating you on the progress of your stack creation activity. And when that is completed, you can pull down the events menu at the top of the lower half of the console here, and you can select the outputs panel, which will take you off and enable you, or outputs button rather, which will take you off and enable you to see the outputs that you defined within your stack. And you'll recall in our particular example, we were using the instance ID as one of the outputs that we were going to be taking a look at. So next, I'm going to show you what happens when you make an update to your template file and you wish to update your stack. And you can see here that I've edited my resources, or edited the resources section within my template to add a security groups attribute to my EC2 instance. In this case, wanting to use a security group called SSH tools to enable me to SSH into my instance. Now I've deliberately made a syntax error here in defining this particular attribute, and if I then attempt to update my stack by uploading that new version of my EC2 instance.template, go back through the process of specifying my parameters, click next and update my stack, you'll note that at this point I'm provided with details in the events panel of the console explaining to me that my update has failed. This is a very helpful feature in debugging stack creation and update, enabling you to work out any issues that you might have within your templates. Here my update fails because the value of property security groups must be a list of type string. Okay, so I can then go back again and correct my syntax, which I've done here, turning that particular property into a list by putting those square brackets around it, and then repeating the process again. And you can see that in this particular example, my update is now successfully completing, and I have a new EC2 instance that's been created, which has the appropriate security group. You can see there at the bottom right of the screenshot. And you can see that my old EC2 instance has been terminated, and I have a new one now with a different instance ID as a result of running that update stack operation. So it's important to note there that resources such as EC2 instances are replaced during the update process. Okay, and of course after that you can then go to the console again and execute a delete stack operation, which I'm doing here. And you can see that similarly the event panel will be populated with the operations that are required to delete my stack. Again, going through step by step and providing you with feedback on the process of deleting down your stack of resources. And visiting the console again, the EC2 console at this point will show, of course, that my resources have been successfully cleaned up, and the EC2 instance created by this particular CloudFormation template in that stack has been terminated, and I have no more resources that are running. Okay, now this is obviously really helpful in enabling you to exercise good discipline over the control of your AWS costs. It's very difficult, almost impossible in fact, to have resources that might be orphaned if you always create and delete resources using AWS CloudFormation, which is a really beneficial feature of the service for helping you maintain good control over your cost structure. So that's a kind of side benefit of using CloudFormation, which many customers tell us is really valuable. Now, of course, in common with all AWS services, you're not restricted solely to using the console. You can also use the command line and API in order to execute the same operation. You can see here example command line command AWS CloudFormation create stack, and passing parameters like the stack name, the template URL, and the parameters for our key pair parameter being passed in, and that will return back to you the details of the created stack in the output format of your choice in accordance with your AWS command line tool configuration. In this case, we're getting that back in text format. Okay, so that just shows you what comes back when you execute the process on the command line. And of course, the command line and console are interchangeable, so stacks that are created using the command line will of course be visible in the console, and stacks that are created in the console will of course be available through the command line if you wish to, for example, list your stacks or describe your stacks. Other actions that are available to you via the CLI, you can see them listed here. And as usual, you can get more details of precisely what the command options are by using the CLI itself. So a command like AWS CloudFormation update-stack help will print back to you a help page, synopsis, and more details about the syntax of that particular AWS CLI command. If you're not familiar with the CLI, this is the same for all AWS CLI commands. There's comprehensive documentation available within the CLI tool itself. And of course, if you want to use the API, then the command line itself is built using the CloudFormation API. An exhaustive discussion of the CloudFormation API itself is probably beyond the scope of this session today, despite the fact that it's a masterclass. That's a little bit more than we're going to have time for. So if you want to learn more about the CloudFormation API, then check out the CloudFormation API reference, which you can access by visiting the URL that you can see at the bottom of this slide. And of course, if you download the materials from today's webinar from the files panel in the webinar interface, or visit them on SlideShare if you're watching this on demand and download them there, you can of course just click through to these URLs. Okay, so that's a quick tour of using the console and command line to create, update and delete stacks. And now we're going to talk about working with resources. So firstly, working with AWS resources and defining resources that you're going to create within your stack. First thing to say is this is designed to use your existing experience with AWS. So each resource within CloudFormation has a set of parameters with names that are identical to the names used to create the resources through their native API. There's a comprehensive template reference available at the bottom of this slide if you visit that URL that you can see there. But in essence, it's probably best explained by taking a look at a couple of examples. So firstly, creating an EBS volume. You'll see its type is AWS EC2 volume, and then its properties, things like the size, the snapshot ID, the availability zone. If you've used EBS previously in the console, you should recognize these as the headings of the console if you're listing the EBS volumes that have already been created, or the fields in the create volume dialog that you're presented to in the console. So you can see there's strong alignment between console, API and CLI for many AWS services as a result of the way in which these tools are built and depend upon one another. And that construct is carried through into CloudFormation. A slightly more complex example, creating a security group resource. The name is AWS EC2 Security Group. The properties, once again, you'll find very, very similar to the headings in the security group console within the EC2 console, VPC console, and similar to the command line attributes, arguments that you might use when creating a security group on the command line also. So once again, you can see there's alignment between console, command line and API. Service support within CloudFormation is very broad. This is not exhaustive, by the way. There are additional services now that have been added to CloudFormation. Run out of room on the slide to get any more on here. And you can find full details on the services that are supported on the CloudFormation product detail page, which I'll show you a link to at the very end of the session today. But pretty much every AWS service that you would want to work with is supported by CloudFormation and can be included in your stacks as resources. So what about referencing the properties of other resources? This is important for a couple of reasons. The main reason that this is useful is to do with namespace collisions, or rather avoiding namespace collisions. Obviously, if you're going to use the same template multiple times to create multiple stacks within the same account, it's not going to work particularly well if you've got statically defined resources in there, things like security groups, for example. Excuse me, you'll tend to get clashing. One of the ways you can avoid this is by using reference functions within your templates to allow you to back reference to resources that have been created within the same template. Here you can see an example where we're creating a reference called instance security group, which is later used to create a security group itself. And these resources will be given execution time names by CloudFormation itself, rather than you having to be explicit about what the naming of these resources are. So it enables you to back reference resources and make use of the same template to create multiple stacks, whilst at the same time avoiding namespace collisions. So it's a very, very powerful tool, the use of referencing. Of course, there are situations where you may need to refer to resources that have been created outside of CloudFormation. What if you've got a pre-existing VPC with security groups in it that you wish to make use of, or you wish to statically define a key pair that you're going to use for SSH access to instances, or to decrypt Windows administrator passwords on your instances? You can use literal references for that. You see the quoting that we've used here with my existing SG or my key enables us to reference pre-existing resources within our account, but reference those from within CloudFormation templates. Importantly, there are checks here. So that key pair, for example, if there wasn't a key pair in existence in that region with the name my key, stack creation would fail as a result of that. So you just need to be aware of that also. The other kind of referencing, of course, is referencing input parameters, something that we've already talked about a little during the session with that example that you can see here again, using references to a parameter within a resource and having those parameters collected at execution time or specified at stack creation time, to be more precise. And use the console as one mechanism for doing that. You can, of course, as we've already illustrated, pass these parameters in via command line, API, and of course via SDKs that wrap that API. And you can validate input parameters. Here you can see an example of validation. So we're here defining a input parameter called WordPress user with a default, with a description, with typing, in this case a string, and then with a set of validation parameters. We want it to be between 1 and 16 characters in length. We want it to contain upper or lowercase, start with an upper or lowercase alpha character, and then have alphanumerics for the remaining characters in the string. So, and that allows you to obviously do things like use regular expressions to validate IP addresses that you might require within templates and other more complex constructs of that nature. So you can use regex, regular expressions in that particular context as well. Moving on, conditional values. This is important, and one of the reasons it's important is because there are, for example, region-specific parameters that you might require within a template. Taking our example that we used previously of creating an EC2 instance in a particular region, if we wanted to make that template portable across different regions, then we may need different AMI, Amazon Machine Image IDs in those different regions. And you can use mappings as a mechanism for handling this, creating these region maps where you may define, as you can see here, a two-level map with the top-level keys as region names, and then a subset of tuples containing the AMI IDs that we're going to be using. So that enables you to have templates that are portable across regions and can be used in a variety of different regions without modification. So in this particular example above, the image ID property of the resource EC2 instances, it uses that FN finding map function to determine its value by specifying the region map as the map to use, AWS region as the input value to map from, and AMI as the label to identify the value to map to. And this would allow you, for example, in this particular example, if you were going to create a stack in US West 1, it would automatically set the image ID to the AMI ending in 0A20 in that particular scenario. So that's a very powerful tool. There are a number of other intrinsic functions that are present within CloudFormation to help you deal with more complex use cases. For example, the base64 function, which returns base64 representation of the input string. You typically use that to pass encoded data to EC2 instances through the user data property. Finding map we've talked about already, finding values corresponding to keys in a two-level map declared in a mapping section. Get attribute, which returns the value of an attribute from a resource in the template. getAZs, which returns an array listing all availability zones for a specified region. Join, which allows you to append a set of values into a single value. You're separating those by a specified delimiter, and we'll show you in a few minutes a use case for that. Select, enabling you to return a single object from a list of objects by index. And ref, enabling you to return the value of a specified parameter or resource, which you've already seen used in that example with security groups just a few minutes ago. And then there are also a set of pseudo parameters. For example, notification ARNs, which returns a list of notification Amazon resource names for the current stacks. Region, which returns a string representing the AWS region in which the resource is being created. Stack ID, which returns the stack ID specified with the CFN create stack command. And stack name, which returns the name of the stack as specified with the CFN create stack command. So you've got those functions that you can use for creating some very powerful constructs inside your CloudFormation templates, and we'll show you some examples of those in use when we come to talk about bootstrapping in a few minutes. Working with non-AWS resources, here you're in a position where you can define custom resources, enabling you to use non-AWS resources in a CloudFormation stack. Now, again, this is probably a little bit beyond the scope of this session today. We could spend quite a lot of time taking a look at this, and I would like to point you off to a couple of external resources if you want to know more about custom resources. The first is a session actually from AWS reInvent 2013, which is called AWS CloudFormation Under the Hood, which has an extensive walkthrough of I think 3 or 4 different use cases for custom resources, together with implementation details for those, so you can take a look at that. And there's a custom resource walkthrough documentation set as well available, which will walk you through creating your first custom resource and making use of it in your inside an AWS CloudFormation template. Next thing we're going to do is take a look at bootstrapping applications and handling updates. And there's a couple of different ways that you can approach application bootstrapping with AWS CloudFormation. The first option is to continue to use EC2 user data. Now, EC2 user data is available as a property of the AWS EC2 instance resource type. And you can see actually in this example, use of several of those intrinsic functions that we covered just a few minutes ago. So we're using find in map, we're using base64, and we're using join to concatenate user data, in this case a shell script, to be executed via the user data field on a Linux instance, to encode that as base64 and pass it into the EC2 resource within that user data property. And you can see this particular example is installing a variety of different packages and deploying a Rails app as its final step. Okay, so that's one way you can do it. Second option you have is to make use of some helper scripts which are provided by CloudFormation for deployment within your EC2 instances. And there are 4 different helper scripts available to you. CFN init, which is used to retrieve and interpret resource metadata, for example doing things like installing packages, creating files, and starting services, and we'll take a look at some examples of that in a second. CFN signal, which is a wrapper to signal a CloudFormation wait condition, allowing you to synchronize other resources in the stack with the application being in a state of readiness. CFN get metadata, another wrapper that enables you to retrieve all the metadata defined for a resource or path to a specific key or subtree of the resource metadata. And lastly, CFN hup, a daemon to check for updates to metadata and execute custom hooks when changes are directed. So that can help you manage application updates using CloudFormation. CFN init is something that we're going to take a quick look at now. And that can do a variety of different things. One of those is to install packages as specified or install and expand files that might be listed as sources, and you can see examples of that in this code snippet where we're using the AWS CloudFormation init property here to configure a set of packages, in this case MySQL, MySQL Server, MySQL Libs, the Apache Web Server, PHP, and the PHP MySQL libraries, and expand and install sources, in this case grabbing a zip file that you can see there at that S3 URL in the CloudFormation examples bucket, and expanding that into var www/html on the file system of this Linux instance. So that's use of CloudFormation init helper to do package installations and also expand and install files at particular locations in the file system. In order to make use of CFN init, you do actually need to bootstrap it using user data. You can see here an example of using user data to install and execute the CFN init helper script and enable you to make use of the extensions that we showed you on that prior slide. You can also directly create and write files onto the instance file system if you wish to do that. Here's an example of creating a setup.mysql file. Once again, we're making use of the join intrinsic function to create a text file on the file system of an instance which contains references from the stack. So for example, the reference to DB name and DB username, they will be stack parameters gathered at stack execution time and then written into the file system on a specific instance where this was used as a key. And then lastly, the services key enables you to start services and also ensure that services are available upon reboot if you set enabled to true for specific services. In this particular example, we're using that services key and we're enabling and starting the MySQLD and the Apache HTTP daemon using that services key. So that's just a short snippet showing service control using CFN init. If you want to know more about deploying applications with CloudFormation, then you can visit the URL at the bottom of the screen there. It will give you a lot more information about bootstrapping applications with CloudFormation, including much more detail about CFN init and the other helper scripts that we described briefly there. And yes, all of this functionality is available for Windows instances too. This is a very common question that comes up when we're talking about CloudFormation. Many of the examples here are Linux, but you can use all of this functionality for Windows instances too. And we have several large customers that are making extensive use of CloudFormation, actually not only with Windows instances, but in a very, very responsive continuous integration, continuous deployment tool chain. One great example of that here in the UK is Just Eat, the restaurant takeaway food was a startup. It's now a very large company. They make very extensive use of CloudFormation as part of their deployment tool chain for their applications, which are developed largely in Microsoft.NET and are running on the Windows platform. So they're using CloudFormation to enable them to update and deploy their applications as part of their CI/CD toolchain in that particular case study. So I can guarantee that all of this functionality is available for Windows and is used in production at scale with the Windows platform. Another common question here is, what about other configuration management tools? What about Chef? What about Puppet? How does CloudFormation interwork or integrate with tools like Chef and Puppet? And it's a very commonly asked question, and we've got tutorials actually helping you to integrate CloudFormation with Chef and with Puppet, available on the AWS CloudFormation articles and tutorials page on the AWS website. So if you take a look at the URL that you can find at the bottom of the screen here, you'll find walkthroughs and best practices for making use of CloudFormation in combination with either Chef or Puppet, using CloudFormation to bootstrap the agents that you need to get Chef and Puppet running on your instances so that they can be the authoritative configuration management tools that you use, but CloudFormation can take care of instance creation and the creation of all of the other AWS resources that you might need to enable you to run the applications that you're going to manage using Chef or Puppet. So we're almost out of time. Just to summarize, CloudFormation, it's an easy way to create and manage a collection of AWS resources. It allows for orderly and predictable and repeatable provisioning and updating of resources. It allows you to version control your AWS infrastructure, enabling you to get closer to this idea of having your infrastructure defined as code alongside your application and other data. And you can deploy and update stacks using console, command line or API, and that affords you many integration opportunities if you wish to take advantage of them. So a very quick summary of what we've covered during the session today. Of course, if you have questions, please continue to submit those. And we'll come to those at the end of the session, right after we've talked about resources that you can use to learn more about AWS CloudFormation. And the most important, of course, is the CloudFormation product detail page on the AWS website at awsamazon.com/CloudFormation. Pretty much everything I'm going to show you on the next slide is actually linked off there. So that's the one go-to location that you can use to learn more about CloudFormation generally. Some resources, if you're getting started and you're new, check out the Getting Started guide. It will walk you through the process of creating your first ever CloudFormation stack with a helpful walkthrough that you can take advantage of. Also, take a look at those CloudFormation templates and samples. It's a kind of commonly told joke amongst the AWS solutions architect community that the best kind of CloudFormation template is one that you stole from someone else or didn't have to write yourself. So do make use of those templates and samples. You can use them in many cases as complete solutions for deployment challenges you might be facing, or use them as a basis for customization and creating your own CloudFormation templates which fit your use case perfectly. And a couple of examples of how far you can go with this. The first is to say that there's a tool, open source tool developed by AWS, which is a high-performance computing deployment framework built on CloudFormation called AWS CFN Cluster, a HPC deployment framework. You can find that on GitHub at github.com, AWS Labs CFN Cluster. So if you're interested either in high-performance computing workloads or in the kind of ultimate evolution of what you can do with CloudFormation, then take a look at that tool, and it will allow you to explore both things actually, creation of elastic supercomputing clusters and seeing how CloudFormation can be used to create a complete execution environment for one particular kind of workload, which is very interesting. And then there are, of course, sample templates that you can take a look at. Here's one example of a CloudFormation template that will deploy a resilient multi-AZ WordPress environment inside AWS. There's quite a complete set of parameters that you define up front, a very complete execution set of resources that are created, and of course bootstrapping actions at the end. So a good way to take forward your knowledge from this session will be to download this or another one of the templates available in the sample templates, load it into a text editor of your choice, turn on JSON formatting support, and just take a look at precisely how these things work and what the constructs are that are used to create the functionality that's required to deploy a complete application using AWS CloudFormation. A very good way to learn more about how this service works and how it might work for you. If you're interested more generally in AWS training and certification, we have quite a few resources available now. Self-paced labs which are available. There's a complete classroom-based training curriculum from AWS focused on particular role types. So developers, systems operations professionals, and architects. If you want to know more about that, visit aws.amazon.com/training. And we have a certification program that goes alongside that now, where you can have your skills validated and certify as an associate AWS developer, systems operation or architect, systems operations professional or architect, and as a professional level architect or systems ops professional. So if you're interested in certification around AWS, take a look at aws.amazon.com/certification for more details. Also coming up very soon, we have the AWS Summit in London taking place on April the 15th. You can find full session details as well as register for this event, which is a free one-day training and technical deep dive event for AWS customers and prospective customers at aws.amazon.com/summits/London. And you'll find AWS CloudFormations featured very extensively in one of the technical breakouts there, Deep Dive Infrastructure as Code, which will feature at least one, probably two AWS customers talking about their implementation of infrastructure code using infrastructure as code, using CloudFormation and actually other tooling as well. So I'd like to encourage you all to register for the summit, join us for that event and learn more about CloudFormation and about other AWS services that might be useful to you or your organization. So that's all we have for you today in terms of content. I'm going to turn over in a second and take a look at a few of the questions that have been submitted during today's webinar, but here are those social media details that I promised you at the beginning of the session. So you can find me on Twitter at IanM with 4Ms if you want to stay up to date with the life of an AWS evangelist here in Europe. Find us at AWS_I here in the UK and Ireland for more information and updates on future webinars and other AWS educational events that we're running here in the UK and Ireland. And you can find us at AWS Cloud globally for information about AWS new services, announcements, AWS reInvent, the program of summit events that are taking place around the world. You can find all of that at AWS Cloud. Last thing to do, of course, is to switch the webinar into Q&A mode. Please leave us a rating when you see the ratings box appear. We'd love to have your feedback on the session today. If you've got qualitative feedback, you can leave us that in the Q&A panel. And of course, do continue to submit your questions via the Q&A panel. And we'll turn now and take a look at a few questions and try and talk through a few of the answers to those now. Just like to thank you for joining us for today's session. Thanks for giving us your time. We really appreciate you spending time to learn about AWS. And let's turn to a few questions. Thank you.